I thought Excel was powerful, but this is like, this is how you create Excel, and then whatever else you want to create. All right, so we're going to look at functions. We've already worked with functions some, and what we're going to see today are functions, and we call them func. So it's func in Go. So Go is really about keeping things short and readable, and so we've already worked with some functions already, but we're going to look at them, explicitly today. And we'll see functional expressions. We'll look at closure. How many people have heard of or worked with closure before, Daniel? Yeah? No? Right on, dude. I get to teach Daniel something today. Returning funcs. We're going to look at how we can return funcs. And then, just a little bit of a glance at recursion in Go. And then we'll also talk about the stack versus the heap, which is kind of interesting. Just some of the internals about how the language works and what those do. So functions are in Go are just types. So they're just types. So just like any other type, like an int or a string, right? You could pass an int or a string into a function. You could return an int or a string from a function. And same way with, you could assign an int or a string to a variable, right? Those are types, ints and strings. And so functions are types too. So just based upon what I told you, show of hands, can you pass a function into another function? Yes. Can you return a function from another function? Show of hands. Yes. Can you assign a function to a variable? Yes. Right? Just like you can assign an int to a variable, you can assign a function to a variable, because functions are just types in Go. And that's one of the things that really distinguishes Go from other languages, is Go is really rooted around types, and working with types. It's statically typed, and everything's about type in Go. So you use functions like any other type. You could declare them as variables. You could pass them around just as you'd pass types around. You pass functions just like any other argument or parameter. You could put them into functions, return them from functions. You could declare functions inside other functions, right? So it's very similar to JavaScript. And it's easy to start thinking that, hey, this is like Lisp and Haskell. This is functional programming. Cool. I worked with Lisp and Haskell. But functional programming isn't encouraged in Go. So even though you could do all this stuff with functions, and functions are types, the thing with Go is to keep things as simple as possible. Keep it very clean, keep it very readable, don't make things complex. If you have to write another 10 lines of code to make it like simplistic, write those 10 lines as opposed to making it really clever and complex and difficult for the next person who comes in and inherits your code, or you 6 months later to go back and look at it and figure out what the hell you wrote. Right? So it's really about keeping things very clean and readable and telling a story, right? Telling a story with your code. So keeping it simple. So we're going to look at all the stuff you can do with functions, but at the end of the day, you want to keep it, not do the functional programming so much. So func main is your entry point for your program, and that's always got to be in package main. So we've been seeing this since day one. Right? And function declaration begins with the func keyword, and then you have your function name, and then the parentheses, are where you're going to pass any arguments. And then after that, right in this spot, is where you have your returns, and then you have your curly braces. And so this is scope right here. So if I declare something inside, we talked about scope already. If I declare something inside those curly braces, then that's the scope of whatever it is I declare. It's inside those curly braces. And so that's the main thing. Sometimes functions can start to be a little confusing. You just have to remember that before you have a keyword, and then you can have something called a receiver right here. And then you're going to have the name of the function, and then you're going to have your parameters, and then you're going to have your returns. So that will become more clear as we see examples. But you got to have func main inside package main. That's the entry point for your program. So there's a parameter, right? So I'm declaring a function, and the function is greet. That's the name of the func, and I'm saying that it has one parameter, and the name of the parameter is name, and it's of type string. And then I'm using that function, and I'm passing in an argument. So just clarifying between parameters and arguments. So a parameter is like, when you declare the function, that's what you're saying this takes. An argument is what you pass into it. trying to be precise about the terminology I use when talking about this stuff. So that I understand when I read things, the difference, parameter, argument. Most people just blend those two together. That's how most do it, right? But when you look at like the language spec, they're going to be very precise about the difference between a parameter and argument. So here we have func main greeting. So if I'm going to call a function, if it has no parameters, right, I still need to put those little parens around it to run it. I couldn't just put greeting there, right? This is what runs it. Just like I had the parens here, and I pass in the argument. This one takes no arguments. It doesn't have any parameters, right? So I still have to have those parens to call that function. And you could pass in. You could have multiple parameters, right? So functions take unlimited number of parameters, and we saw this with variadic arguments. So with the variadic arguments, it's ... params, and then it's argument ... I don't know if that rings any bells, but that was the syntax on it. Maybe we'll see that again. We probably will. So pretty straightforward. And you don't have to declare the type each time. So if it's the same type, you could just say, f name, l name, and they're both strings. And then I could keep adding to that if I wanted to, just another comment. I could do some ints or whatever, or float 64s. And there's my return, and I say what type is being returned. You can name your returns, but my mentor in this language, who's brilliant, and I showed you the book he wrote, and I've been to a couple of his trainings, he says, don't do that. That's not clean. That just sort of pollutes your code, right? Doesn't keep it clean, so it's better not to name your returns. So I'm not even going to show you that, but just want to let you know that that is something you could do, and when you do come across it, just like in your own head, if you want to go based upon faith, from what I learned from one guy, just, we don't use that stuff. It pollutes the code, makes it overly, makes it less clean. That's his phrase. That's Bill Kennedy's phrase, pollutes the code. So, well, heck, here's a named function just so you could see it, right? And you can see that's, which way is a little cleaner, right? Either way, I don't know. Don't do that. So you can have multiple returns. Cool. How cool is that? Multiple returns. But generally speaking, you return one value and an error, which you check. That's like 99% of the time the way you're going to do it in Go. You handle your errors instantly, right? And you return what you need, and you return if there's an error. And then when you call that function, you see if you get the value and the error. And if you check if the error is there, and if there is there, you deal with it. So that's how you do the error checking with Go. So here's the ... notation where I could take an unlimited number of float 64s as a parameter. And then this returns one float 64. And so here down below, I'm calling the average function. I'm passing in a bunch of float 64s. And this is of type kind. So the internals of the Go language, the type here has not yet been determined. And it will do the conversion for you if it can. So even though these kind of look like ints, and you haven't specifically said, like maybe in some languages you would have had to put .0, Go will say, like, this is indeterminate. Like, this might not even yet be on the stack, right? Like, this could just, and the stack is like, I created a variable, and that variable is now taking up memory in this stack of memory that's running for my program. Like, this could just be right here, these values, because they're just literals, could just be right in your registers or in cache. Right, so they might not even have a memory address, and they call that having variables in kind as opposed to type. And Go will automatically see if it can convert something that type is indeterminate, right? It hasn't been determined yet. It'll see, can it be this type? And it'll try to convert it for you. So that's the main thing to take away here is variadic, right? So there's the variadic, and we already saw that. And I could also pass in, like if I had a slice of float 64, right? So there's a list. We're looking at that data structure again. And it's a list of float 64. And I'm passing in it's saying, hey, there's a whole bunch of data in here that is float64. I want you to open that up and pass each of those values. Because up there, that has a parameter, a variadic parameter. And then down here, I'm going to use an argument, which is variadic, and pass in. Right? Since that needs float64s, I can't pass in a slice of float64. Because a slice of float64 is different than a float64. Those are different types. But I could open up that float64 with this notation and pass in each of the float64s. You should know that already, right? Parameter name does not have to match argument name. Like, these are two different variables. The scope of data is right here, and the scope of SF is right there. Slice of floats is why I call that SF. So it's pretty easy to think San Francisco, given where we live. That's my first thought. I saw SF. I'm like, why did I call that San Francisco? What's going on in that one? Oh, it's a slice of floats. All right, so here's an exercise. Let's all do this in code, because the only way you learn is by coding. I want you to write a function which takes an integer and halves it and returns true if it was even or false if it was odd. For example, half of 1 should return 0 false, and half of 2 should return 1 true. All right, so if this seems like a bit of a stretch, because that's a little bit challenging, there's actually some thinking that's going on there, some logic. Just create a function. Like, create a function. That's it. Just create a function and then call the function. So if you want to do that first one, if you feel like you're more at that level, just create a function and then call it. Pass in some sort of an argument. Declare your function to have a parameter and then pass in an argument and get that running. And if you feel like, oh, I've totally got this stuff, I like challenge, Daniel, then write a function that takes an integer and halves it and returns true if it was even or false if it was odd. So the first step should just be the logic, right? It takes an integer. So somebody give me an integer. I'll be the function. Give me an integer. 57. Now I'm going to have that. Uh-oh. Daniel's being tricky. Right? Half of 50 is 25. So I got 25. Half of 7 is going to be 3.5. So I got 28.5. Right? Halves it and returns true if it was even or false if it was odd. 27.5. True if it is even, halves it. So half of 57, so that's going to be false, right? So 1 should return 0 false. So really what we need to maybe think about is modulus. And so it'd be 57 mod % 2. And if it returns 0, right? So that means it's even. And so that'd be true. So you might think about that logic. Anyhow, give it a go. See what you come up with. And if that one's too complicated to think the logic through, just do a function that you could call and return something. I've got the solution. I'll put it up in a couple of minutes. And eventually, once we learn all the syntax, we're going to apply it to data-driven websites. You're already